Okay, today we're going to work through sections 19 and 20, beginning Unit 3 and dealing with financials. So, here we go. There we go. All right, so let's do this week. We've got two sections in web work, 19 and 20. Section 19 is all about credit cards. Section 20 is all about interest. So we're going to talk about bad interest with credit cards and good interest with savings accounts, basically. And then you do have an Excel credit card assignment. There is a video that goes with that. I think I've already posted that, actually. And then we have quiz 11 and discussion board 11. And we need to talk about next week. So next week, I'm actually not going to be available on Wednesday. I'll be traveling, and therefore we will not have a live session next week. That's sections 21 and 22. I will post an old video of sections 21 and 22. I'm actually out of town Monday, Tuesday, and Wednesday next week. So if you would like a live session on either Thursday or Friday, I do have open time both of those days during the day. So just reach out, let me know, and we can make it happen. Otherwise, I will try to post an old video along with this one so you can kind of watch Becky specials for those sections as well. And we'll go from there. So I will also post an announcement to remind you that there will be no live session next week on Wednesday. All right, so section 19 is credit cards, and just kind of a little bit of background, right? So credit cards, pretty much at this point, anybody can get a credit card if you have good or bad credit. Obviously, if you have better credit, so you have loans and you make payments on time, that's how you build your credit, showing that you can manage debt and making payments on time, paying down those loans. That's how you build your credit. And the better your credit, the lower your interest rates on credit cards, and generally the higher your credit limit. So, if you have a low credit score, that implies that you struggle managing debt. You don't always pay your bills on time. And if you have that issue, then they're going to give you a higher interest rate, so you pay, higher interest. So when we talk about credit cards, and there is a spot in your packet that kind of gives you a general terms and conditions of your credit card, you'll see that there are fees associated with credit cards. Some credit cards have an annual fee. You have to pay to have it. Personally, I think that is crazy. I would never pay to have a credit card. All of my credit cards that I have are no annual fee. You just have them to have them. But you can have an over-the-limit fee. Right? Every credit card has a limit. If you spend more than that limit, they give you a fee. If you make your payment late, you get a fee. If you make a late payment or go over the limit, that can also trigger you into a penalty APR. So your interest rate could go up, potentially. But return payment, insufficient funds, there's all kinds of fees that can be associated with credit cards. In general, if you use a credit card, you have a grace period generally before you are charged your interest or your finance charge, our second bullet here. And if you pay off the entire balance before, when you get your bill, you don't have any fees. So, keeping your balance low enough that you can afford to pay it off at the end of the month is really your best bet. You're going to save, you get an interest-free loan every month, basically, is what it is. If you carry over a balance to the beginning next month, that's when you are charged a finance charge. And your finance charge is based off of your interest rate, and your interest rate is generally called an APR. And an APR is what we know as the annual percentage rate. Right? Well, and it's given as a percent. Let's just say 4%. But that's annual. When we make credit card payments, we don't pay them annually. We pay them monthly. So in order to find a finance charge, we're going to have to take that APR and divide it by 12. So that's kind of a general rule. We're going to take our APR and we're going to divide it by 12 because that gives us a monthly percentage rate. And that's what we want. Whether you're using a credit card, buying a house, buying a car, right? All of those things make monthly payments. So we want a monthly percentage rate. So APR divided by 12. And hopefully you remember that we would take that percent and change it to a decimal, and then we would divide it by 12. So that is kind of how we're going to find our finance charges. So let's go ahead and start there. Number one, let's find the finance charge on a $1,200 balance if the APR is 18.99%. Okay, so remember that we want to take the APR and divide it by 12. So I'm going to take my percentage rate. And the first thing I want to do is I'm going to change it to a decimal because we know to play with percents, we want them to be a decimal. And I'm going to divide that by 12. So this yellow fraction is now my monthly percentage rate. Well, once I have my monthly percentage rate, I'm going to multiply that by my carryover balance. So if I have a balance of 1,200 multiplied by my monthly percentage rate, my finance charge is going to be $18.99. So, almost $19 that you are giving to the credit card company for the loan of $1,200 for a month. If you don't pay it off the next month, you will have another finance charge. So your finance charge is always based off of the balance at the beginning of the month. Okay, let's do one more of those. Let's go ahead and find the finance charge of $800 balance if the APR is 26.99%. So you'll see on this one, our balance came down by $400, but our interest rate went up by 8%. So if I take 0.2699 divided by 12, and I multiply by 800, right? So APR divided by 12 multiplied by your balance at the beginning of the month. For this particular example, my my finance charge is $17.99. So it's only a difference of $1. So even though I went down $400 on my balance, because the interest rate is so much higher, we're going to have, a very similar finance charge. So the higher your interest rate, the higher your finance charge generally. Okay, let's see how this all goes together. You're going to be asked to complete some tables, in your homework. And this is what you're going to do in Excel as well. And again, there will be a video posted for this. But I crossed out, we're not going to figure the last part of month 4. So we just want to know the beginning balance of month 4. Okay, so let's talk through how we're going to do this. So Sarah has a $1,400 balance with an APR of 20.99%. She makes no new purchases and only makes the minimum payment each month of 6%. So let's complete the table. Okay, so in month 1, right, she has a carryover balance of $1,400. We always assume a carryover balance unless it says it's a brand new credit card. So if she has a balance of $1,400, our first step then is to find the finance charge. Well, we know from our last examples that we take our APR, divide it by 12, and multiply by 1,400. When I do that, I get a finance charge of $24.49. Now, remember, we're talking money, right? Credit cards all deal with money, so everything should be rounded to the nearest penny. So to find our new balance, well, if I take my beginning balance and I add my finance charge, because the finance charge is additional money you owe, so I add those two together to get $1424.49. Our minimum payment is based off of our balance at the end of the month. Now, I didn't make any new purchases, so I simply have my new balance. So I take my $1424.49, and I'm making a 6% payment. So I multiply this by 0.06, and that gives me a minimum payment of $85.47. Now think about this. If you owed $1424.49, and then you paid $85.47, well, whatever is left after I make my payment, that's how much I will begin the next month with. So I take my $1442.49, subtract $85.47, and I get $1339.02. All right, so new balance minus minimum payment equals beginning balance. And then I start this all over again. So I still have my 20.99% divided by 12. Now I multiply by my new balance of $1339.02. And it makes sense that my balance went down, so my finance charge should also go down. So my finance charge this month is $23.42. It's $1.07 less. The less you owe, the less you pay. Again, I'm going to add these two columns together to get my new balance of $1362.44. And just like last time, I take my new balance and I multiply by my 6%. And that gives me a minimum payment of $81.75. All right, go ahead and hit pause on the video for those of you watching the video, and try to do this last line by yourself, and then come back and make sure it all works. But you want to make sure that you know how these pieces all go together. So go ahead and try it before you watch us finish it here. Okay, so remember, to get the beginning balance of the next month, we subtract. So new balance minus minimum payment gives me $1280.69. And I take my 20.99% APR divided by 12, multiply by my new balance. And again, my new balance went down, so my finance charge is going to go down. So this month it went down $1.02 to $22.40. add these two columns together, and my new balance is 130309. I then take my 130309 and multiply by 0.06 for a minimum payment of $78.19. I then subtract new balance minus minimum payment, and my balance at the beginning of the next month is $1224.90. So when you are working through this section, you then can answer all sorts of questions about this. You can answer questions like, what is the total of the minimum payment? You can add those together. What is the total of the finance charges? You can add them together. How much did your balance reduce? Right? You can ask all of these questions based off of this information here. So your balance would reduce, if you take $1,400 balance you started with and subtract $1,224.90, which is what you ended with, the difference is how much your balance was reduced. So my balance was reduced by $175.10, even though I spent more than $175.10. That's all my balance was reduced because everything else went towards paying finance charges, right? Just a shade over $70 in finance charges, and that's just money you're giving away when you're paying finance charges. So there is that. And that is section 19 in a nutshell. Being able to understand those pieces of credit cards and how they all work together. All right, let's go ahead and go to section 20 with interest. So in section 19, we talk about bad interest in the form of finance charges on credit cards. And now in section 20, we're going to talk more about investing with maybe savings accounts or other pieces, but good interest, right? Interest that the bank is paying you. So we're going to start with simple interest, which is simple. So the formula for simple interest, which is on your formula sheet, is I equals PRT. So I is the obvious one, right? It stands for interest. P stands for principal. Principal meaning the amount you started with. So if I invested $1,000, my principal would be $1,000. R is, what is that? APR, right? R is your interest rate, and it's always going to be given as a percent. So you're going to have to change it to a decimal in order to play with it. And then T is time. And in this case, time is always in years. Okay, and that's something very important to remember. So if I say something about 6 months, T does not have a value of 6. T would have a value of 0.5 because 6 months implies half of a year. So that is just important to remember. Okay, so now that we know what those pieces represent, let's go ahead and get to a problem. So Sarah invests $600 at 2.5% simple interest for 6 years. We're going to answer 2 questions for every one of these problems from here on out, and that is how much interest and what is the balance. So because it tells us simple interest, we know we're going to use the formula I equals PRT. So naturally, we find interest first. So our interest is principal, right? $600 times the rate, well, 2.5%. Move the decimal 2 places to the left, and I get 0.025 times time, and the time is 6 years. So when I multiply those 3 pieces together, I end up with $90. So if this was me, I would have $90 in interest after 6 years. So when I think about letter B, what is the balance after 6 years? Well, the balance is what I started with, right? So the principal plus the interest, because this is good interest. This is the interest the bank is paying you. So after 6 years, my balance is $690. Beginning balance, which is the principal plus the interest. All right, let's try one more of those. Trevor invests $2,000 at 1.75% simple interest for 12 years. Again, because it's simple interest, we're going to go that way first. I equals PRT. So, principal is $2,000. The rate, we move it 2 places to the left, so I get 0.0175. And this one is for 12 years. When I multiply those pieces together, we have an interest amount of $420. Remember that your balance is the principal, right? The amount you started with plus your interest. So I'm going to start with my $2,000 principal plus my $420 interest. And after 12 years, Trevor will have $2,420. And that's simple interest. It's pretty straightforward. You use the formula to find the interest, and then you use your logic of what I started with plus what they gave me together as my ending balance. All right, now let's go to compound interest, which is not quite as straightforward. So the formula for compound interest, your packet gives you two different formulas, but essentially they're the same thing. So here's your formula. B equals P times 1 plus R over N raised to the N times T power. And you know what P, R, and T, right? Principal, rate, and time. We had those, time still in years. This B represents the ending balance. So unlike simple interest, the formula finds the balance, and then you can work backwards to find the interest. We're going to do that here in just a minute. We know what P is, we know R, we know T. N, which you can see is here twice, and that's where this comes into play. N is the number of times you compound in a year. So what does that mean? Well, if it says compound annually, well, annually means N is 1, because annually means once a year. Well, so it's whatever word follows compounded. Compounded monthly. Well, there are 12 months in a year, so N is 12. Quarterly. Well, quarter, think about quarter. Quarter means N is 4. So whatever word follows the word compounding, that tells you how many times you're doing it per year. There's your value of N. All right, so let's go through a few of these and kind of see what happens with these formulas. Assume a $1,200 deposit with an APR of 3.5% is compounded annually for 4 years. Now, since it's compounded annually, our formula leads us to finding the balance first. Okay, so let's go ahead and highlight our pieces. Compounded annually means that N is 1. So when I look at my formula, principal is $1,200. Inside 1 plus my interest rate is 0.035. N is 1. And then I'm going to take it to the N times T power. Now, compounding annually is fabulous, and hopefully you already recognize that, because if I simplify this, anything divided by 1 is just itself, and 1 times 4 is just 4. So this is why your packet uses two different formulas. It uses a formula for compounding annually, because you can see how it simplifies, and then it uses the more intricate formula for the other ones. Well, I don't think you should have to memorize two formulas. Well, you don't have to memorize it all. It's on your formula sheet. But this is the same formula. The compounding annually formula just means that N is 1. So it seems silly to think about it in two different ways when it's just the same formula. So you will need to make sure you know how your calculator works with these. And so if you can't figure out your calculator, take a picture of your calculator and send it to me. I'm pretty well versed in a lot of calculators, and I can pretty much tell you what buttons to hit when I'm looking at a picture. So if you need help with that, just shoot me a photo of your calculator. So the balance is $1,377.03. So after 4 years, this is going to be the balance of this account. Now think logically. If I started with $1,200 and I ended with $1,377.03, how much interest did I have? Well, the interest is the difference between what you started with and what you ended with, right? We assume there are no additional deposits in this. So if I take what I ended with, $1,377.03, and I subtract my initial $1,200, the difference, $177.03, is my interest. So finding these things, simple interest, compound interest, they're a little bit backwards, right? Simple interest, we found the interest first, and that led us to the balance. With compound interest, we start with the balance, and we work backwards to find our interest. Okay, let's do another one. A little bit more exciting. Assume a $2,000 deposit, compounding monthly for 8 years with an APR of 1.5%. Okay, so now we're talking monthly. So that means n is 12. So when I go into my formula, I have principal, 1 plus 0.015 divided by 12, raised to the 12 times 8 power. Now, depending on your calculator, it is possible that you might have to simplify this fraction first and multiply these together first before you plug in the whole thing. And that's really calculator dependent. Some of you will be able to type it in exactly like you see it, right? For exponents, you're looking for either the caret button. This implies the next piece is an exponent. Or you might have a button that's y to the x. That implies the next piece would also be an exponent. So one of these two buttons. Either way, the answer for this should be 2254.82. And that is your balance after 8 years. Well, think back. If this is my ending balance, and this was my beginning balance, the difference, 254.82, is my interest. Interest is the difference between what you started with and what you ended with. All right, let's do one more of these with a different compounding. And I would say the same thing for those of you who watch the video. Pause it. Try to do this on your own before you come back and watch the video. So a deposit of $600 with an APR of 4% compounded quarterly for 30 years. Well, quarterly means that n is 4. So what's the balance? Well, the balance is the principal times 1 plus the rate. The rate is 4%. We're talking quarterly, so we divide by 4. And then our exponent is 4 times 30. 4 times 30 is 120 if you wanted to do that. All right, so after 30 years, my balance would be $1,980.23. So if I want to calculate my interest, we take my ending balance of 1980.23, subtract the 600 I started with, and say thank you to the bank who gave you $1,380.23 in interest. And that is that. All right, so that's compound interest. I did the formula a couple of different times. You can kind of check that out. The last part of this section is the rule of 70. Depending on what you read, you might see it talked about as the rule of 72. But basically what this is it gives a prediction of doubling. Okay, things doubling when they are at an annual growth rate. Or growth annually. Okay, you can talk about money, you can talk about population, you can talk about anything. But this is how it works. They're basically saying if something is growing at an annual rate, if you take 70 and divide it by the percent, that will give you the number of years it will take to approximately double. And this is an approximation. It is not exact. It is an approximation. And it doesn't matter your amount. Because we are dealing with percentages, it'll approximately double no matter what the amount is. So 10 becomes 20, 40 becomes 80, 6 million becomes 12 million. The amount doesn't matter. It's the percentage, and that's why it works. Okay, so let's do a couple of these, and we'll call it a day. How long will it take for money, it doesn't matter, to double if the APR is 5% compounded annually? And remember, it is important that it's compounded annually, because anything more than annually compounds at a quicker rate. Compound interest is based off of the money in your account. And every time it compounds and you get interest, it adds to your balance. So your balance is constantly going up. And that's why it has to be annual. Okay, so we would take 70 and divide it by the percent. Well, in this case, our percent is 5. So 70 divided by 5 gives us 14 years. So if this was your deal here and you put money in at 5%, your money is going to double in approximately 14 years. So, if you were investing and you're like, hey, I want to put in $10,000 right now, if they say, we can get you about 5% return, okay, well, 70 in 14 years, your $10,000 will double to approximately 20. And that's kind of what you're looking at here. And these are approximates, right? They're not exact, and they're definitely not guaranteed if you're talking about investing. Okay. So, I looked this up earlier today that it was 2016 number. I think it was an annual or an average of the annual in 2016. The population of the U.S. increased at a rate of 1.6% that year. So yearly growth rate of 1.6%. How long before the population doubles? So when you think about this, right, so we're talking about doubling with an annual rate. So we take 70 divided by the percent. Well, our percent is 1.6. So 70 divided by 1.6 gives us approximately 43.75 years. That's kind of scary to think about. Assuming the U.S. population continues to grow at a rate of 1.6%, it's only going to take like 44 years for the population to double. We have like 324 million people right now. If we would double to 648 million, that's a lot of people in the same amount of space. But I mean, as of March 2017, the growth rate was down a little bit from this. So it does vary from month to month. But it's still kind of interesting to think about that, in some of people's lifetime, because I may or may not live for 44 more years. But to see that the population could potentially double is very, very, very crazy. So that is the end of section 20. So make sure that you complete the assignments for this week. And remember, I will not be here next week. So I'll post that other video as well. And if you have questions, as always, I'm available through email. Let me know what's going on. And yeah, I'm going to need to send you an email because I think I'm out the following Wednesday as well. So we're going to need to talk about some things. So yeah, we'll do that. So have a great week, great weekend, and I'll see you guys in a couple of weeks. Okay, thanks. Bye.